Welcome. In this video session, let us learn more about the periodic table. Periodic table is a fundamental aspect in the study of chemistry because if you know about the periodic table well, the trends in the periodic table and certain terms, it becomes very easy to predict the physical, the chemical properties of the elements that we see in our universe. Human nature is such that it does not like chaos. It wants to organize everything so that anything that we want becomes easily accessible. In a pile of books, finding the book of my choice becomes difficult. Whereas if I arrange them in a particular order, the order which can be either alphabetical, author, or by subject, or whatever, you see that selection of the book becomes very much easier. A similar problem was faced by chemists long time back. They discovered lots of chemicals one after the other, and they tried to find out the physical and the chemical properties. And somehow they've tried to arrange them in one particular order. Initially, they started putting them together based on physical properties, then they started putting based on the chemical properties and various other aspects. Then they started finding about the mass of the elements and trying to arrange them in the order, and finally they thought that atomic number was the best way to determine which element it would be, and hence right now we have the arrangement of all the elements in the form of a table which is called as the periodic table of elements. Now when elements were trying to be arranged in the form of their properties and so on, there were certain parameters that were kept in mind. The first one was the atomic number, then the radius, which actually tells us the size of an atom. Then it is the ionization energy. We have already seen what ionization energy is. It is defined as the amount of energy required to remove the most loosely bound electrons. Here we talk about only the first ionization energies, and generally the rule is that the element has to be in the gaseous form, gaseous atom, and once I take out an electron, it should form a cation. So that is what we define as the ionization energy. And the other one is the electron affinity. Electron affinity, as the name itself suggests, it is the affinity for an electron. Now when an electron binds to an atom, you can see that there is a change in the energy of a neutral atom, right? Now this change in the neutral atom is its ability to gain an electron, and that is called as electron affinity. Ionization energy always leads to the formation of a cation, whereas electron affinity, since the electron is added onto a neutral atom, it is giving rise to an anion. So this energy change is also considered to arrange elements in our periodic table. Then we talk about the metallic and the non-metallic character. The metallic character is basically defined as you can say how readily an atom can lose an electron, right? And the non-metallic character is basically the ability for it to take up an electron. So that would be the metallic or the non-metallic character. Again, quite important and dependent on ionization energy and electron affinities. One more important parameter based on which our modern periodic table is formed is something called as electronegativity. Basically, electronegativity is nothing but the measure of the tendency of an atom to attract a bonding pair of electrons. So this is very important because this determines most of the chemical reactions and the bonds that an element would form. Okay, so how do I measure the electronegativity? Now that electronegativity is measured by a scale which is called as the Pauling scale. The Pauling scale is a very small scale whose values range from 0 to 4. We see that fluorine has the highest electronegativity Fluorine has the highest electronegativity, having the value of 4, and the lowest is seen with an element in the first group, which is called as the francium, having a value of 0.7. So this is also an important parameter which determines the position in periodic table of elements. Now let us talk about one very important aspect of why it is called as a periodic table of elements. Now it is called as periodic table of elements because it is the elements that we are arranging. So we know why the elements is included in the term. Now why is it called as a table? It is because all the elements are arranged in the form of a tabular column. Why is periodic term present in this particular terminology? It is because all the elements in the periodic table show a property which is called as periodicity. Now what is periodicity? Periodicity is nothing but a kind of repeating pattern, and this repeating pattern is repeated at regular intervals. Now this is something which is very important. The pattern is repeated at regular intervals. Now what exactly is getting repeated? You see that they can be our atomic properties or physical properties or the chemical properties. This periodicity is so important in the arrangement of elements that it's called as periodic table of elements. Once we know what exactly is periodicity and why it's called as a periodic table of elements, the next thing we should know is what is that on which our atomic, physical and chemical properties are showing the periodicity. So what is the factor on which the atomic, physical and chemical properties are dependent upon? Now this is dependent upon something that is called as atomic number. We know atomic number is nothing but the number of protons in an atom, or it is the number of electrons present in a neutral atom, right? So that is something which is determining most of the properties in our element. Hence we call this as the periodic table of elements, where the periodicity is seen with increase in their atomic number. Just to make the idea very clear, there are two tables that are given here, one which shows about the period 2 and the other one which is about the period 3, and let us just compare certain elements here. Now in our periodic table, lithium is followed by sodium, beryllium followed by magnesium. They are in the same rows, and then you have boron and aluminium together, and so on. Now let us do one thing. Let us just look at the type of bonding and the structure that it shows. You see that the first two elements show metallic properties here. The first two show lithium, sodium, beryllium as well as magnesium. Both of them show a metallic bonding. And you look at the last row, you see that the fluorine, they form a covalent bond, right? So even if you look at the molecular structures, you see that there is a lot of similarities in their atomic, physical and chemical properties, which we will learn in a little while. And you also realize that the periodicity is seen with increase in their atomic number. If you compare, the lithium is not similar to fluorine. In fact, you see lithium is a electron donor, whereas fluorine is an electron acceptor. Okay, you can see one forms a giant lattice, the other one forms a simple molecular structure. But you can see that there is a similarity between lithium and sodium and fluorine and chlorine. So this clearly shows that there is a periodicity at regular intervals as the atomic number increases, right? Okay, so this is how our periodic table looks like. You can see that all the elements are arranged in the increasing order of their atomic number. It is arranged in the form of increasing order of atomic number. So you have the first element, which is hydrogen, having only one electron and one proton, and then you have helium farther away but you see that it is also present in the same row. So hydrogen, which is having only one proton, and helium, which is having two electrons, they both are placed in the same row. The next 8 elements, you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. All these are placed in the second row, and then you have the third row, fourth row, and so on. Right now, this arrangement is what we call as the modern periodic table of elements, and this was proposed by a scientist by name Moseley. It was proposed by Moseley. However, the basic skeleton structure was given by Mendeleev, who is also called as the father of the periodic table. Now, if you look at the periodic table, you can see that all the elements are arranged based on the increasing order of their atomic number. And as we have already seen, there is a regular periodicity that is observed. Now, all these elements are grouped together in one particular column based on the properties. Now, the first group of elements that is circled here is actually a group of metals. You can see all these elements given in this block are actually willing to give away their electrons for the bond formation. The first group is the one which is highly reactive because they just have to give away the electron in the valence orbital, right? And then you have the second group and so on, and this group consists of our metals. Now this group, which is on the right of the periodic table, consists of nonmetals. Now these are the elements which are not giving away the electrons, but they are in need of an electron, right? So we call them as the nonmetals. So based on their ability to give away electrons and the type of bond that they would form, we have classified and grouped all the metals and the nonmetals. Now, the property of giving away electrons and taking the electrons and forming what kind of bond is completely dependent on the ionization energy, the electronegativity, and some of the parameters that we just described. And this is dependent on the electrons of the element, where exactly they are, whether they are in the S block, P block, D block, and so on. So you can see that in the first few groups we have the S block elements. So these are the elements which are called as the S block elements. Now in this S block elements, you see that it is the S block that gets filled up. So when we write an electronic configuration, I am sure we write 1s2, 2s2, 2p6, 3s2, and so on. Now in the first period, there is one S that gets filled up. So here it is 1s here, 1s2 in the helium. Then you have the 2s that gets filled up, then the 3s, 4s, 5s, 6s, and the 7s, right? So you have 1s, 2s, 2, 3s, 2, 4s, 2, 5s, 2, 6s, 2, 7s, 2, which gets filled up successively, and this is what we call as the S block elements. Now after S, what gets filled up? It is the P block elements, right? It is the P block, right? And such elements are all grouped together, and we call these as the P block elements. We call this as the P block elements. S block is also called as alkali metals, and P block elements consists of our nonmetals. One more group of elements where the D block gets filled up. Now that group of elements are called D block elements, and they are situated in the center of the periodic table. So it is the S that gets filled up first, then it is the P that gets filled up, and later it is the D that gets filled up. Now these D block elements are also called as the transition elements, because you can see that very gradually the metals get transitioned to the non-metals, right? So we call them as the transition elements too. Now the last orbital that gets filled up is the F orbital, and you can see all the F block elements, or the elements where the F block gets filled up, placed together separately in the periodic table. Now you might be wondering, why is it that it is taken out from the periodic table and placed as an attachment to the periodic table? That is because when we're talking about the periodic table, we said that there is lot of similarities in a group, like lithium and sodium are related in their properties, sodium and potassium are related, potassium and rubidium is related, and so on. But when we are talking about the F block elements, you can see that there is a lot of similarities, not between the groups like cerium and thorium and so on, but it is more with respect to the period. So it is that the similarities are seen not in the columns but in the rows, and since it could not be arranged in existing periodic table, such elements were taken out. You can see that there is an asterisk here just after 57, here and here, where these elements which are from 57 to 72 are the F block elements, which are called as lanthanides. And then you have 89 to 104, which is 90 to 103, which are called as actinides. Now this F block elements are taken out of the periodic table and they are placed separately, only because instead of seeing a lot of similarity in the group, you see that there is similarities in the elements belonging to the same period. Hence, this is the arrangement that's done for the periodic table. Now let us try to find out which elements would represent the most reactive groups. You see that the most reactive groups are the groups which are present in the periodic table in group 1 and group 17. Group 1 elements are very reactive because they have only one electron in their valence shell, whereas if you look at the group 17 elements, you have one electron less in their valence shell, right? So this has to, group 1 has to give away the electron and group 17 needs an electron. In fact, you can see that very commonly you can see that these group 1 and group 17 form bonds together. They form an ionic bond together to give us some salts like lithium fluoride, sodium chloride, potassium bromide, and so on. The best way to do that is take a periodic table and fold it such that lithium, this block, is overlapping on this block, and you can see that such salts are quite common in our nature. So this is the most reactive groups in the periodic table. And which one do you think is the least reactive group? Obviously it is the group 18. Now why group 18? Because you see that their valence shells are completely filled. So here you can see that the 1s is completely filled with 2 electrons. In the second period, you see that S2 and P6 are completely filled, and so on. So you see that since this last group has completely filled electrons, they are considered to be very stable. So we consider them to be the least reactive in the periodic table. Let's talk about the strengths in the periodic table. Now this is something which is very important for the chemist, right? Now we have arranged all the electrons based on their atomic number, physical properties, chemical properties, and so on. And now if I just look at the periodic table, it should kind of give me an idea of what exactly is the trend, so that I will be able to compare two elements that's given to me. Now you can see that every time I go down the periodic table, the atomic radius increases. Why does that increase? It increases because every time I move down the period, you can see there is a new shell that's getting added, and therefore the size of the atom increases, which means to say the atomic radius increases. Whereas if I move from left to right, you see that the atomic radius decreases. Now why does this decrease? This decreases because every period I go down, you see that there is an increase in the shell number. There is a new shell that is getting added to the element, and hence the atomic radius increases. Whereas if I move from left to right, you see that the atomic radius actually decreases. Or putting it the other way, if I move from right to left, the atomic radius increases. Now, why does this happen? This happens because there is increase in the nuclear charge as I move from left to right. And when there is an increase in the nuclear charge, the ability to pull the electrons closer to the nucleus increases, and hence you see that the atomic radius actually decreases as I move from left to right. Now, talking about the metallic character, always towards the right there is the metallic character, and then you have nonmetals grouped in this region. However, you see that the metallic character always increases as I move from this part of the periodic table to the left lower part of the periodic table, and the non-metallic character increases as I move from francium to fluorine. It is very easy to remember ionization energy and electron affinity. It always increases from left to right. And you also see that electron affinity and ionization increases as I move up in the periodic table. Now, if you just remember this particular trend in the periodic table, it would be easier for you to compare elements belonging to the, it is easier for you to compare the given two elements, find out their, compare their ionization energies, electron affinities, and all that, and you can be able to predict what kind of properties they would show. So with this, right now we have a fair idea of what is the atomic structure of an element, and how the atomic structure determines various properties of an element, and how I can arrange all the elements present in the universe in the form of a tabular column, which helps me to remember many of the properties, right? So this is a chapter which is very important in general chemistry, because if you know periodic table and atomic structure quite well, you can try to predict. You can learn and understand most of the general chemistry very easily. So wish you all the best. See you soon. Thank you.